the new work was 3D. So I got myself a copy of the OpenGL Bible and boned up on 3D. And for the last couple of years, I've become a convert to 3D. And you know, I'm hoping that today, this presentation, to cover a few different things. In particular, I'm going to look at, you know, this whole idea of the possibility. Since this is a labs presentation, a lot of this is a little bit speculative, but we've been working now in Brisbane on this product, Qt3D, for a little while as a labs project, and we're hoping to make a release before New Year, so maybe we'll start becoming a little less speculative and a little more real. I'll have some URLs at the end of the presentation where you can actually download our entire source code from our repo. As I mentioned, you know, my background is working with the C++ side. So if you guys are C++ hackers, then we're talking the same language. But I'd just be interested to know, do we have any designers in the room? People who consider themselves graphical people. Has anybody ever produced a 3D asset model? Yeah? Awesome. Great. Blender, maybe? No? Yeah. All right, very good. So a few hands are going up there. One of the things that we're excited about is getting people like, you know, myself, to C++ engineers and designers working in, you know, a nice little team unit with tight iterations by using scripting. So I'm interested to find out about that. You know, I think if you think about the sort of work that most of you do, how many of you guys are maybe designers as well, but are also C++ engineers? Yeah. Keep your hands up if you've written some 3D code ever. OpenGL bindings. Yeah, a few grimaces and laughs. It's not easy stuff to work in. All right, well, that's great. You know, what I hope is that even if you've worked with C++, that maybe you can become a convert, like me, and you know, try to hand over a little bit of the control that you have with C++ over to the scripting side. Obviously, there's some trade-offs there, but we're pretty excited by what's happening just in some early developments. All right, so what I'm going to cover is our QML 3D bindings for Qt3D. And I'm just going to talk a little bit about the background, how we got to where we are with our bindings with the Qt3D project. And that necessarily comes from the C++ side. A lot of this presentation is going to be me actually doing some live coding in QML. So I'm going to make a prayer to the gods of live demos and hope that that comes off, despite my being a little unwell. And then I'm going to wrap up after the demo by just trying to sort of pitch again, draw together some threads and try to say that, you know, that this is why it's exciting to use scripting. And we'll mostly hold over some questions until the end. But however, I'm bound to make some mistakes while I'm typing in my code. So please scream out and jump about and point out my mistakes. So I realize that those won't go to the recording, but it might just help me recover, get to where I need to be to get this thing running. All right. So a little bit about the history of 3D. All right. So how did we get here? You know, back in the day, 3D was pretty technical stuff. You know, some guys in lab coats with high-end hardware trying to produce, you know, some sort of realistic 3D effect on the screen, using a lot of heavyweight computer science. You know, around the sort of dawn of computing, really, you know, working on some heavy mathematical transformations. And as we sort of moved forward, along the timeline of the development of computing, you had folks like SGI, Silicon Graphics, producing some high-end hardware and also putting a lot of time into the software required to actually get effective and compelling 3D effects. Back then, of course, you had ray tracing. We've heard that term a couple of times already today. And ray tracing is the idea that you take a pixel on the screen and you trace it back from the physical screen into your model. So you have this 3D model that represents the structure of your imaginary 3D world. And from there, each light source that contributes to where that pixel is projecting from is carefully calculated using 3D maths and the angles of incidence of these various light rays. Very time-consuming, very technical, and a big pain in the ass. The games guys who were starting to come, to the fore when, computers became personal, they really didn't care about all that stuff. They wanted some responsive experience. It needed to be, compelling enough, but they really didn't care so much if we cheated a little bit. Maybe we didn't really need all that clever ray tracing. We just wanted some shortcuts to get some stuff on the screen. And around that time, SGI eventually produced the OpenGL standard. And in a way, you can see that as a bit of a compromise, because really the triangles that are represented in an OpenGL model, as triangles are pushed out onto the GPU, you take a pixel back from the screen to one of those triangles, you're really not lighting it from all different sources. You've got a lot of shortcuts there that are producing lighting models, and especially in shader-based implementations, we can take any shortcuts we want to give the impression of a lit pixel. Obviously, there's other hardware and software platforms that became available, and then we saw this massive explosion of popular 3D, because by making a few shortcuts like that, what we could then do is get a really compelling effect in real time in response to user interaction with the computer. Pretty nice stuff. And of course, rapidly after that, there's a profusion of high-level frameworks. And this is kind of where we came in about this sort of time. We already had our Qt contribution, the OpenGL widget, which really wasn't a framework, but we started building up our Qt 3D Labs project, and it slotted in around the same sort of position as high-level frameworks like Ogre, Crystal Space, some of the other frameworks. Obviously, commercial frameworks. There's a zillion and one incredibly powerful commercial game production frameworks for like Unity and so forth. And those are really not the sort of thing that we're competing with in many ways, and I'll just mention that in more depth very shortly, but Qt 3D sort of fits in that slot. It was meant to try to give you access to OpenGL, but to do it in a way that gave you a little bit more generality. And then finally, here we are, getting towards the end of 2010, and we've got religion, and we've discovered QML and our own bindings. So that's very roughly the timeline. You can see that things are happening very fast, and we're making some guesses here. We don't know how right we are. We're sort of hoping that that we're going to produce some results that people find useful, especially with this idea that tight iterations can help programmers and designers work together. So coming to the future a little bit more, Qt 3D started with just one guy, my compatriot in Brisbane, Rhys Weatherly. He started in 2008, and really what he was trying to do was to track the OpenGL API with Qt 3D and bring Qt, that programming experience that you guys all love, yeah? There's no non-Qt lovers in the room. Good. Okay. What Qt does for you is it makes the normal sort of job of programming, very simple. You can create a push button, just a few lines of code. Memory is sort of managed for you a little bit with the QObject ability to parent your heap created objects. So, you know, some of the pain that comes with C++ programming is taken away. The problem we have, of course, is that you get inside an OpenGL widget in Qt, and suddenly it's not Qt anymore. You know, you're out on your own, you've got the red book, and go have fun. It was really up to you. Suddenly, you didn't have all those nice Qt abstractions. You had portability issues with OpenGL. Even though you were writing a Qt program, you suddenly had to write a lot of hash if defs to get around platform inconsistencies. And that's particularly noticeable when you get to the difference between OpenGL ES, that's the embedded subset for our handheld devices, versus the desktop. ES was, you know, a strict subset, so in theory it should have been easy, but there's actually a lot of problems. The function names are different. When you go to ES 2.0, of course, it's shaders only, and obviously, you know, desktop implementations are very, you know, shaders are accessible and available and becoming, you know, primacy really is going to shaders. But you'll still see a lot of material every time you try to learn OpenGL, look at existing programs. A lot of them refer to the fixed function pipeline. So all of these portability hassles come to haunt you when you try to get programs that are going to run on devices and the desktop. So what we were trying to do way back when was just this simple idea that we would solve some of those problems for you. 4.6 came along, and we got a few wins there. Our QGLShad program. Has anybody used QGLShad program? Yeah, a few hands up there. Okay. Thumbs up, thumbs down. Like it? Yeah? It's a lot easier, isn't it? Right. You know, so we were starting to get this thing. You didn't have to resolve a lot of extensions to try to find out if you could use shaders, and it ironed out a lot of those problems. We also had our math class, a few math classes actually, but QMatrix 4x4. Those guys dropped in and are now part of the main Qt source tree. So that was the beginning. But then, you know, the glory went to our heads a little bit. I came on the scene, and show pony that I am. And we started to think about, I'm sorry, those graphics, they look fantastic on my laptop, not so great up here. But we were starting to think then about, you know, the actual, what we think of as real 3D. So, you know, as they mentioned on the presentation this morning, 3D can mean a lot of different things to a lot of different people. Maybe it means funny glasses in the movies, etc., etc. But can I say it this way? 3D models, you know, and that's a model both in the sense of some mathematical model inside your program and an actual digital asset. 3D models exist in some synthetic world, right? And they result in images being projected into a 2D bit plane. And then potentially you can have some additional hardware, stereoscopic hardware like shutter goggles, the sorts of passive glasses that you get when you go to a 3D movie. Those things make consuming 3D content more compelling, perhaps. But at the end of the day, what we're really talking about when we say real 3D is it's these models generating this synthetic world, if you like, the scene that's going to be rendered. Now, as I said before, that got very, very hard. You just want to get something on the screen, and you've got miles and miles of this complex C code, because that's really OpenGL API is all C-based, and you're managing memory. It's a real pain. To get a simple model from something like the 3D Studio Max format, the .3ds file, or a .obj file. To get those guys on the screen was a lot of work. So you might have some simple model in a file. It's not like Qt anymore, right? What happens with Qt, if I want to load a PNG, I can just create an image and pass the file one line of code and it's there. What we were hoping was that we could make it that easy to load models as well. I wrote the 3ds loader that we're currently using, and I've also built a scene graph implementation that tries to optimize the way models are displayed. So you just may have heard Gunnar Sletter's presentation where he talked about the new scene graph, which basically comes up to the 2.5D level, working with QML, trying to make QML look good. Well, our scene graph sort of comes down from the top, and there may be some blending of the two ideas, but it does things, for example, like if I have a big synthetic 3D world with objects here and there, my camera might be pointing in this direction. And as a result, the view frustum, that's the volume that's projecting out in front of our camera, everything inside that is visible. All the stuff over here is completely invisible. So there's some very basic optimizations that you can do with a full-on 3D scene graph just by looking at basic object coloring. So we do that, for example. If you've got a big scene, a bunch of models displaying, our scene graph implementation at least culls out the ones that are not visible. So we were really looking forward as we got on from this tracking of the OpenGL API. We were thinking, okay, well, the next thing people are going to want is some basic Qt-style primitives to just get some stuff up on the screen, some sort of high-level stuff. And, you know, that stuff all came together. We hired a couple more people. But then we were thinking, yeah, we sort of done it, right? We sort of have brought the Qt story to 3D. Who the hell was going to use it? That was the problem. You like it already? You're going to use it? Man's signing up.
We are very looking forward to it. And
the comment there was that they're really looking forward to it, and the 3D engine is needed. So that's really great to hear. I think you're right. You know, we're definitely on the right track here, and I guess what we were hoping was that, you know, we had this wrapping of the APIs, making things easier. Potentially, there's always a cost to some portability abstractions, but we were still in C++, so the cost wasn't so great, and it was going to make it a lot easier to actually get your code working. We were, you know, hitting the nail on the head with the loading of 3D files, and what we really thought was, well, C++ engineers like myself, like most of you guys, we know about that stuff, but designing UIs and, you know, getting that really compelling user experience, that really only comes when you have, you know, your designers and programmers working together. And if you've got something like Qt Designer, you can drag and drop your images and so on. What we wanted to see, we thought, was, you know, to get creative types into the picture as well, so that maybe teams would be the people who would use it. People who wanted to, you know, get some kind of C++ application up with performance as a goal, but also they wanted to actually have some you know, nice 3D content arranged in a way that functions as an actual UI, an actual user interface that you could actually, you know, get something done. I'd be really keen to walk down the corridors of DreamWorks and see how it is that they actually work with 3D content in these user interfaces that they have running there. So this was the big question. We didn't want to jump the shark. We didn't want to try to go too far. We didn't want to eat the lunch of people like Ogre and, you know, Unity and some of these people with ultra high-end engines. But we also wanted to try to help people out so that they were going to get their applications written. by providing, the most basic things, making the really simple things possible, which has always been Qt's story. And then, of course, QML arrived. 4.7 was coming on the track, and it was the next big thing. So we did some hacking over Christmas, and by early this year, we discovered that it wasn't that hard to put some bindings in for our Qt3D C++ and make it possible to actually load and even animate by applying some of the typical QML animations to these 3D models that were allowing us to actually load up. And it was kind of exciting. Just with that experiment, I think we really started to realize that maybe what our focus could be was that Qt3D would ultimately become simply an enabler for the QML 3D scripting bindings. And there's a parallel here with other 3D development environments where it's often the case that you'll have C++ in the back end doing some heavy lifting, and then there'll be various forms of scripting. And in a way, shader languages are scripting, but JavaScript to provide that ability to alter your application during the cycles that go in at the end, where you're making the actual visual appearance of your application different. You've got the functionality in place, and you're really wanting to get it looking good. All right, so let me see if I can show you some QML 3D here. Now just bear with me, because I'm going to do a little bit of typing. And my aim is, I think, hopefully worthwhile, because what I want to show is that you can quite quickly achieve a realistic result. I'll just mention a few things. When I give you the URL to our labs repo in a sec, you'll see where you can download our Qt3D source tree, but here it is right here. You can see we've got a bunch of classes in here for handling things like geometry and scene nodes and stuff. My scene graph stuff is in there. In here in our scene format stuff, we've got loaders for a few different formats. Once you download that, it's the same as building any other kind of Qt project, although this one's getting a little bit bigger now. I've already built that just to save us a little bit of time, but now what I'm going to do is so the idea here is, just to diverge just for a second, the QML 3D bindings are good for a certain class of 3D application. And, we were searching around, actually looking on the app stores to try to find, what was these killer 3D applications. Obviously games is huge. But, you know what I found? The next thing after games was guns. Couldn't believe it. So if you search around the app stores of various places, there's these gun applications where you can have your phone and you pull it out and there's a 3D model of a gun on there, and you can fire it and stuff, and the magazine comes out, and I guess if you're a gun nut, you just want to have all those bits sliding apart and the magazine sliding in and out, and I don't know. Maybe I was expecting porn. But guns, anyway. So what is this good for right now? Yeah. What it is really good for right now is applications that look like models moving around and sliding about and bits and pieces animating. So let's see how we can do that. I'm just going to open the wrong dialog. I'm going to create a new project here. It's going to be a cute, quick UI. I'm going to call it demo. It can go into my documents tree. Okay, so it's already set up a little project there for us with a project file, and we've got our demo QML file already created. So to get started, the first thing I have to do is actually import our 3D plugin. When you run the build script for Qt3D, it'll actually create a 3D import library, which then gets installed into the Qt tree. So you've built your Qt, and wherever that is, our plugin library will get diverted and stuck into the imports tree of that Qt tree, so that it can get found. And by doing this, I just import it there. Now with most QML stuff, you have some kind of rectangle and stuff so you can see things on the screen. The first thing you want when you're doing a QML 3D app is just a viewport. I'm going to give this a width of 1000 and a height of 700. Alright. Now, I've got my thing there called Demo QML. There's a couple of different ways to actually run QML 3D applications right now. One is to actually use the conventional QML viewer, and that mostly works. We actually have a couple of issues with it. The most poignant issue is that the lovely 3D navigation that we've built up with our C++ QML view class, that kind of disappears when you use the declarative viewer. We have created a JavaScript navigation item that creates mouse areas and so on the screen, and that actually works pretty well. So if you're creating a QML 3D application that blends both 2D and 3D, I do have some demos of those. In that case, yes, you want to use the QML viewer, but I'm just going to work with 3D content just for this one. So what I'm going to do is I'm actually going to run my little QML 3D executable from Qt3D, and it's going to access my demo QML file and run it for me. I'm just going to check that I spelt that right. Yeah. Okay. So if I go back here, and we've got a big black screen of nothing. Hurrah! No mistakes so far. Thank you for the round of applause. All right. So we heard today that we need cameras, so let's give ourselves a camera. And I'll put the eye of the camera in position. I'll start off, let's say, a little bit up in the air, 7 units up in the air, and I'm going to put it a long way back along the z-axis, so I just don't want it to get too close to our scene just yet. Now here's the real gravy for our application. It just allows us to actually display some 3D stuff on the screen. Now, for this app, imagine I'm some kind of roving anthropologist, and I'm studying the religious behavior of certain creatures. So, you know, I want to model how this behavior, and my asset team have produced for me some lovely 3D models that are going to allow me to you know, work away with my QML script to display a little scene so I can study them. So the way I collect up my 3D assets and display them on the screen is I create a little item 3D like this, and I tell it that I'm going to have a mesh, and the source for the mesh will be my, let's see what meshes I may have here. Alright, so I've got you know, a monkey, and I've got a penguin and stuff. That's looking pretty good. I think I'll use those. So let's make them part of my application. One of the things we're hoping, in fact, I've been working on a little 3D viewer thing that could be a plugin to create a allow you to just go and fetch some of these assets. So right at the moment, it's just a little more clunky. But what I have to do at the moment is just manually drag stuff around. So I've put my meshes now into my little project there so that I can refer to them from my QML file. So the source is going to be the meshes directory underneath there. And what did it was monkey.3ds, wasn't it? Alright. So there we go. I've got my monkey file. Now let's see what that's got us. No need to compile, this is a script. Oh, there it is. Well, hey, we have something already. You can see that it really is 3D. I can scroll around and I can zoom in and out and stuff. But you know, my asset team have kind of fallen down on the job because I have a chunky monkey. Right. Well, it turns out that I've actually got some options that I can supply to the loader, and I can force it to be smooth. Yeah, that's better already. Okay. Now, to give our little monkey here some more involvement with our scene that we're building up, we'll set him to a sensible position. So I'll push him back the other way along the z-axis and set him just off to one side. Now, to give him some significance, we'll also colour him a different colour by adding an effect. And let's see, we'll make a material. I'll define this elsewhere rather than putting it in here, because maybe I'll use the material on something else later on. So my material is going to be, let's see, got some nice colours written down here. I'll set it up so that I can reference it from the other parts of the program. Any of you OpenGL programmers that put your hands up before, you'll recognize these values. These are classic fixed function pipeline OpenGL values that Qt 3D actually has shader implementations in it, so that if you're working with shader-based, you get all the nice convenient stuff and standard sort of ambient specular lighting models all come in the part of the package. So that's a sort of a yellowy, goldy sort of a colour for our monkey. And we're going to make it a specular high white, so it's very, very shiny. And continuing with our shininess theme, we'll make it 200. This is out of 255, so he's a very shiny monkey. Hey, there he is. Or he's already looking very sort of iconic, I think. Okay. Now, time to add some more models. One thing we notice is that I've applied a scale there for our monkey, and he's in a nice orientation already, but it doesn't always work out that way. Sometimes what happens is you'll get some digital asset that just needs a little massaging before it's actually going to look right in your application. So we'll see how that thing works out here. Our Penguin had a mesh of same thing. By the way, if anybody sees me make a mistake, if you beat me to the run button, and I'll give you a chocolate fish prize or something. Hopefully, alright, so what does that penguin look like? Yeah, not so good. He's lying down on the job. Alright, so we're going to have to fix that. I'll add some transformations in here. First one's going to be a 3D rotation. Now I'm going to label this one because I might want to do something with it. And we'll have a initial angle. I want to tilt him up, but just a little bit off the straight vertical, so that he's just going to be leaning back, looking up in awe at his golden monkey there. By the way, a lot of this presentation was developed by my colleague in Brisbane, Danny Pope, and he's published that on YouTube. So obviously this presentation is going to be videoed, but if you want to tell your buddies about it, they can always go and look at Danny's YouTube video as well. A lot of what I'm covering right now is up there. So this is going to be the one that stands him up, so I need to make it around the x-axis. And the next one is going to be around the y-axis, just to get him facing in the right direction. This can be his facing transform. Make him do a complete about face. It's getting pretty nice. One thing Danny's presentation did not have was Qt Creator. It's a lot easier with the nice QML integration. Some things don't always work out of the box. I'm working with the very latest build of Creator here, and sometimes the completion works and other times it doesn't. It's a good day, so you guys are in luck. Alright, so things are a little flaky just there, but you can sort of see the promise of it already. So this one's around the y-axis again, so I'm going to change the direction he's facing in. Now hopefully after that, I think I'll make him a little bit smaller as well. He was kind of dominating the scene there before. So what have we got now? Oh, that's much better. An adoring acolyte looking up at his monkey god. Okay, so now that's all very interesting, all that static stuff, but what we really want to do is see some action. So I'm going to add an animation, and we don't need some kind of special animation for 3D. I'm just going to use the same animation objects that ship with QML. I'll make this one infinite, and it's going to be a number animation where the target is the penguin tilt. The property we're going to animate on the tilt is the angle, and it's going to go to minus 45, say. So that'll take him from there to there. And we'll do that over 600 milliseconds. And I'm going to make an easing curve so that it looks nice and sort of natural. we'll use the quadratic curve here. Should give us a nice result. And then, of course, I need to animate him back again. So our sequential animation will perform first this one, then that one. And that needs to go back to our original -100 over the same duration. All right, let's see what that brought us. Hey, hey. All right. Not quite a complete state of religious ecstasy, so I'm just going to make him a little more animated even still. Now here I use this nice little feature where I refer to my parent's properties, simply saying sequential animation on Y, where Y is the vertical translation property in the 3D space. And what I'm going to do with that, add another one, running true, loops, animation dot infinite. It's going to be a number animation again, same sort of trick. This one, we don't need to specify target because it's already there, but it'll be just a little bit up in the air from where he is. It'll be a 200-second duration, and because I'm low on imagination, I'm going to use the same easing curve as before, because it worked so well last time. And coming back, second in our sequential series, it'll animate him back again. Now what do we got? There he is. That's much better. Hopping up and down with glee in front of his idol, his golden idol. Very good. So that's looking quite good, but you know, even with QML, that was a lot of work. And if I want to start spicing up my scene with a whole lot more penguins, I don't want to have to cut and paste all of this code. So what I'm going to do is use QML's ability to create little reusable components quite easily. So I'll grab all of that code there, take it out, and I'll ask QML to give me a new file. And my new file is going to be a QML file. And I will call it penguin.qml. Can go into our project along with our other stuff. And I'm going to drop all of that penguin code right in there. Now, I also have to add our import here so that we know about 3D stuff. Now, what this should do for us, as long as I've typed everything right, is I can now just create a penguin just like that. Let's see if that worked. If it did, I should have exactly, yeah. Okay, so we've got the exact same thing as we had before. Anyone tell me what's going to be wrong with this? Yeah, these guys are going to be jumping on each other's heads and we won't see anything different. Alright, so let's put them in some different positions. Let's see, I just want to have them spread out a bit, sort of from left to right. So, let's see if I've got some good numbers written down here somewhere. Yeah, that looks like reasonable spacing. Use that. Now, as I mentioned, a lot of these digital assets, the idea would be that you could produce the basic structure of your program and then ideally have some creative plugins based on our little model viewer program. I'll just see if I can actually persuade this to actually start up. I'll show you what I mean. Okay, so here's our model viewer viewing a simple 3D scene with some kind of asset that's been produced. And it turns out that I can translate that backwards and forwards. I can scale it up or down. And then I can save a QML file. And that will give us the same thing as our penguin. Now this is kind of pretty yucky. As you can see, I'm not a UI programmer, but the idea would be that something like that could be part of Creator, and it would mean that I wouldn't have to just try to figure out these numbers in my head. I could try out a few different things in the scene and rapidly get the nice effect that I'm looking for with my little anthropological adventure. So he's going to be on the other side of the x-coordinate space, and back a little bit along Z.
The previous one, you missed the set code.
Chocolate fish prize for that, man. Spotted what I missed. Yep. Yes, that would have been nasty. QML would have complained. These guys are going to be a little bit more towards the front. A bit further back. Let's see what that looks like. Not that, but awesome. I love it already. Okay, and of course, you know, we're using the scripting facility to declare all of this stuff in a declarative way, but once it's uploaded onto the GPU, all of this stuff is going to work with sort of the native speed. So the manipulations and stuff can work quite nicely with even more limited processing power. So I'll just see if I can show you that much working on EN900 here. It's a good job I took off that David Hasselhoff wallpaper I had on here. It would have been very embarrassing. Monkey, thank you. There it is. Thank you. All right. Monkey everywhere. I'm sorry that's a little bit hard to see. I should have made the background blue. But, yeah. So, on the SGX, it turns out you can have lots and lots and lots of penguins. I did these penguin models in Blender, and I think they've got about 5,000 triangles in them, each one. Of course, only one copy of that set of geometry has to get uploaded, and all we're doing from there is just a simple translation each time. So it has no problem with that. There is another model that I'm just going to quickly add on our desktop one that has a very, very large number of triangles, and I did try running that on the N900, and it tells me that an SGX out of memory error. So all right, but QML has some more for us with our ability to hierarchically structure things. What I'm going to do now. Okay. Thank you for that. All right. Because I can nest objects to create another item, another 3D item, I can actually apply a higher level animation to this whole group of penguins. So I'll just do that now. Now, thanks for bearing with this demonstration. I think it's worthwhile just seeing how you can do this all live. It does animation to actually, you know what I've done? I think I want running true there, don't I? I'm not a QML expert. There's probably many of you out there who know QML a lot better than I do. Yeah, that's better. So we're going to run a number animation again. Actually, I'll have to put in the actual transform first, which is going to be rotation 3D, with an angle. And given swivel, what axis do you reckon this is going to be around? Anyone? Y. Awesome. Of course it is. So until we get our nice little creator embedded asset management system, Creator's QML completion is actually not too bad for helping me stop from making a lot of egregious mistakes. Okay, so I'm going to do a number animation now with a target of my swivel animation. Same trick again on the angle. It's going to go from the -20 to +20. Let's see. We're going to make this one a lot slower than the other animations so we can actually sort of detect it. It doesn't all run in sync. And we'll do a similar animation back the other way, back to our original value. Yeah, there we go. Well, I can't believe I've got this far without actually having QML crash on me. Well, at least spitting out a complaint because I've given it the wrong result. Nice. So we've got our nested tree of objects where I've embedded our 3D assets along with the transformations on them and the animations on those transformations and the materials all in the one source file. I'll just add one more little asset here. It's going to be another item 3D. Nearly there. We've got to have our stage for our now this thing is really big, as I mentioned. It is a massive mesh, so I'm going to scale it right down. These guys are going to sit on it, so this is probably going to be out by a bit. I'll try 6.0 and set it back a bit. Now the mesh is our lintel that we saw before from our meshes folder. Whoa. A little bit of a problem with our orientation of our lintel there. Let's see if we can move it around a bit. Transform, which will be a rotation 3D. Thank you, Creator. Around, don't need to ID it, 90 degrees. Around X, I think. Actually, I think it's going to turn out that it needs the curly brace. Okay, I did see that, but thank you. Yes. Brain is very slow today, I'm sorry. Oh, yes. Actually, maybe I have that upside down. Let's try it up this way. That's better. There they are, idolizing on their place of worship. Okay. How much time have we got? I can actually quickly add a... Let's see. No, that's not working. What used to happen was I put the light source, our little penguins would be carrying flaming torches and the light would track backwards and forwards across there. But yeah. Anyway, you get the idea. So for a certain class of application, it's quite compelling. You can very quickly sort of build up, something out of these components. If you've already got the meshes, you can apply these rigid body style animations to them. We're working towards some more sophisticated animations. A lot of these digital asset formats will actually ship with a whole range of different types of animations. And basic keyframe animations are probably next on my list. When I get back to Brisbane, my boss is going to be saying, where are those damned animations? So not too hard to do, especially with shaders. You can basically interpolate between a target and the source mesh to get that sort of stuff happening. All right, so I'll just wrap up now. How are we doing on time? How much
15 minutes left.
15 minutes? Okay, so just to try to draw this stuff to a close, I guess if this was a sales pitch, what I'd be trying to say is that these are the ways that scripting works very nicely with 3D. Hopefully you're already converts to the idea anyway, but a good way to think about this, like you might come up against someone who says, well, hang on, aren't I going to lose performance? I mean, when Google released its O3D browser plugin, you had JavaScript driving 3D. And yes, there are certain types of applications where scripting is not ideal. If you want to have integration with physics engines and so forth, then that stuff's going to have to come in via C++ pretty much. But there are some really awesome synergies. And one of the big ones is, as Gunnar mentioned in the presentation just before mine, is that between declarative approaches to building up a scene and your scene graph, you get a really nice ability for optimization. You can think about it this way: like we're pretty used in the C++ world to imperative style programming. Right? I've got hold of the thread of control by its throat. I'm not going to let go, and I'm going to if this and then that, and then things are going to happen. But if you declare everything up front, you create your entire scene at the launch time of your program. You can push all of that stuff up onto the GPU by creating vertex buffer objects, atlasing your textures where needed, and constructing a scene that allows you to do optimizations like culling that are fairly cheap. And that stuff is made so much easier if you've got a declarative type setup, as you do with QML. So I declare the positions and the structure of everything, maybe apply animations to them. But that's probably one of the most powerful things. The second one is this idea that you could maybe hopefully take away when you go back, and if you seek out the creative types, is that really to be successful with applications, not just 3D ones, is you need to have creative guys working with you, and the ability to iterate quickly. Us C++ guys, we can come in, create some new 3D binding. I mean, I hope we don't get too hung up on the way things are just right now. It's very experimental, but we're looking for the next things to add bindings to. This stuff that we added bindings to already is, it's amazing. QML can just suddenly do amazing things with just a few simple bindings. So the next things, of course, is to add bindings for sort of procedurally generated geometry and animations like keyframes and so forth. But what that then does is you've got all that high-performance C++ code doing all that technical stuff, but you can still iterate quickly with your creative people to get exactly the right effect that you want. And of course, prototyping, that becomes possible. You can write quick throwaway programs. Even building shaders. Have we got? We probably don't have time for that demo. I'll run it up on my laptop when we get through. So I'll go to questions now. My details are up top there. If you've got any queries about anything, give me an SMS or an email. These are our mailing list and our labs repo, where you can download all the source. You can build Qt 3D and then run up some QML 3D applications. And there's a bunch of lab posts, and also here a link to Danny's original video with a non-Qt creator enabled monkey god. Questions?
Sorry?
Oh, we have to get a microphone.
Have the microphone here.
Okay.
Let's start here.
All right. Well, while that microphone's traveling, I'm just going to.
So about portability of the OpenGL.
Yep.
Have you considered that OpenGL ES should be enough, especially when graphic vendors are having an OpenGL ES support in drivers?
Sorry, I'm just having trouble seeing where who's speaking.
Me.
Okay. Sorry.
So yeah, about the portability. Do you think that OpenGL ES should be enough for desktop also? Because nowadays desktop drivers have some kind of emulation of OpenGL ES.
Yeah, a lot of the time the right thing to do is to write your application against OpenGL ES anyway, because most of the things that they chucked out when they moved down to limit that subset were the things that were expensive and didn't work so well anyway. OpenGLS 2.0 is shader-based, uses VBOs, so that's a good idea. But even that aside, as a good principle, you've still got the hassle that a lot of your function names are different, the way of resolving extensions, all of that stuff is a headache. Qt3D just Qtifies all of that stuff for you, so you can just get down to the job of writing your normal OpenGL code.
Okay, so you are going to support OpenGL desktop as well?
Yes, yeah. Right across. And for example, what we do with shaders, our shader program library, these guys that have used it already would know, is that the shaders that you write for embedded work just fine on desktop as well, and vice versa. And we do that by using these high P, medium P, low P things that we define. You might have seen some of that happening in Gunnar's presentation. If that was a mystery to you where those guys were coming from, that's our own cross-platform stuff that makes those shaders work on both desktop and ES.
Okay, thank you.
Any more questions? I think they were first over there.
I think this man tried to ask a question before, so he's also been very helpful pointing out my mistakes. So.
Yes, I have a question concerning creating user interfaces with 3D. Yep. Is there currently support for user interaction with the 3D models, like picking?
Yes, we have. I wonder if I can run up one of our. Sorry, clicked the wrong button there. I have a little demo that shows that. I'll just run this up. But there's two different ways. We have our QGL view class that has scroll wheel and all of the different navigation modes. But we also have, when you install our plugin, we have this JavaScript animator, and you get basically the full sort of picking and everything is implemented on both of our C++ viewer and on the declarative viewer as well. So it's there's a very slight limitation in that the way we implemented it was we used colors rather than the traditional picking algorithm, where you trace back a pixel using a special draw mode. So we draw the frame into a color buffer, but because our apps, we're not trying to create some CAD application with tens of thousands of pickable objects on the screen. We can get away with that.
Thank you.
Thanks.
Sarah, in your demo, how comes the material only applied to the monkey and not to the penguins, not to the lintel?
So I created the material inside the viewport, and I gave it an ID. And just the way QML works is that that's actually a very, very good question, because something that always confuses me a little bit. There's a lot of magic that happens with QML, and the magic comes because.
I see. Sorry, you referenced it in your monkey item. All right.
Yeah. So I referenced it using this thing here, okay. But the subtext to your question is, why didn't including the material in line within that item 3D, why didn't it affect everything underneath it? And the reason is that QML has this magic thing where it can add items that you put just into a scope. It just chucks them into a magic invisible variable, and then later on you can go in and inspect that big trash can full of stuff and say, oh, there's that material, and pull it out of there by ID and stuff. And we've piggybacked on that. So, for example, we allow various items to be thrown inside of our viewport and inside of our item 3Ds. If you don't implement that magic trash can functionality. You don't get it for free when you're writing your C++ bindings. And it's basically a case of having to write 2 or 3 Q declarative lists that become part of your object, and then you get that magic functionality.
Sorry, that was actually exactly my second question. Gunnar, in the previous session, almost excluded the possibility to integrate with C++ with his scene graph stuff. So since Q3D actually started with C++ bindings, do you see nice integration with C++ instructional approach?
I think so, yeah.
How would that what would it look like?
The nuts and bolts of achieving it will be interesting, because one of the things that we do, of course, is we screw around with things like GL blending and a whole lot of state. So what would have to happen is we would have to get some kind of window of opportunity where we get hold of the GL context, start doing our drawing, have our scene graph stuff, and maybe hook into the different phases so that we try to reduce swapping of materials and so forth. But I think it's all doable, and the nice thing about that will be that we could have highly performant applications that use both 2D and 3D elements. So I'm trying to sort of think that maybe you're a washing machine parts salesman, right? And you have your little 3D inventory with some 2D lists that are flickable, and then your washing machine part comes up in a little window, and it's in 3D, and you can revolve it around. That sort of thing. But yeah, that's exactly what we want to do. Performance has to be there, but I think it's doable. Any other questions? I think we're almost out of time.
So I guess we should wrap up now.
Yep, okay. Thanks very much.